Just considering the person. Good morning, students. Good morning. So still some students they have to come, right? Okay, fine. Anyway, whatever has been discussed in the last class, I'll be briefing that one. By the time others will also join. Okay? Now, can any one of you send the word which we have discussed in the last class? Can any one of you send the words which we have discussed in the last class? Fast. Okay. People have written molecular mass, mole. Yes, absolutely correct. People are right. But before going for that, before I will forget, because once I start with the class, I will forget. So now, with regard to the notes, yesterday one of the student, they told me that they have not got the check sheet, right? But it's available in the college. You can go to the college, you can get the hard copy. Fine? So that is one thing. So another thing here is, whatever I will be discussing here with regard to the concepts, you have to solve exercise from that particular check sheet. And you should send them to the Rachita madam. Okay? So Rachita madam, you have to send that one to that madam, so that she can go through whether you people have done the mistake or whether it is correct. All of you are getting my point? So that will be like homework for you people. Okay? So whatever exercise problems will be there in those check sheet, it will be like homework. But anyway, anytime, any doubt in that one, you can approach the teacher or to me, whatever it is. Fine? And check sheet, once again I will tell, it is available in the college. You can get the hard copy. You can go to the college and you can take the check sheet. Okay? So now, some people they have written, yes, we have discussed about the molecular weight. Sometimes they will call it as mass. Okay? So then, one student, they had written molar mass. Yes. Then they have written mole. Then anything else? Yes, even people have written. Yes, atomic mass unit. Atomic mass unit. Right? So that's where we have the concept which we have discussed in the last class. Now, when I am talking about mole, atomic mass, and molar mass and all, you can expect the 1 mark question. Define the mole, or what is atomic mass unit, like that. Mole they have asked. Fine? Now, when it comes to molecular weight, it is nothing but sum of the atomic weight of the element present in a molecule or compound. Right? So it is the sum of the atomic weight of the elements present in the molecule or compound. So that's where we have the molecular weight. Now when it comes to molar mass, before going for that, we will discuss on the mole. So what do you mean by mole? It is nothing but a number, right? So that is nothing but Avogadro's number. Okay? So that's where we have got the Avogadro's number. So that is 6.022 into 10 to the power of 23. There is no unit. It's a number. Right? So what do you mean by mole? It is the number of carbon 12 atoms, or it is the number of atoms which will be equals to number of atoms present in the 12 gram of carbon 12 isotope. So that's where we have the mole. Which is that number? This is the one. Please remember, yesterday also I told, if they have asked what is a mole or define a mole, so don't simply write this number. Okay? So you should define how we have got this number. That is not required. But how we got this number, that reason you have to write. What is that one? Because this is the number which will be present in 12 gram of carbon 12 isotope. So that's what we have to define. Okay? So that's where we have the mole. Now when it comes to molar mass is nothing but mass of 1 mole of any substance. It will be mass of 1 mole of a substance. You can extend it as in grams, that is also fine. In grams, it is the mass of 1 mole of a substance in grams. And it will vary depending on the molecule, depending on the element, it's going to vary. Right? So for glucose it is 180 gram. If I take sodium hydroxide, molecular formula for sodium hydroxide is NaOH. Right? Now, atomic mass of sodium is 23, oxygen is 16, and hydrogen is 1. If you add all these things, now it will become 40. So for sodium hydroxide, molar mass is 40 gram. Right? So molar mass is 40 grams. That's why I have extended it as in grams. Right? So that's where 1 mole of sodium hydroxide, that means Avogadro's number of sodium hydroxide will be just 40 gram. So each molecule, each element will have their own molar mass, which will not be variable. Fine? All of you have understood? So that's where we have the mole and molar mass. They are interrelated. Then comes the atomic mass unit, which can be represented by U. The symbol can be U. Now at the same time, atomic mass unit can also be called as Dalton. It can also be called as Dalton unit or Dalton. That is more than enough. If you are telling that one, then in that case it will be, symbol can be Da. Fine? So atomic mass unit, that is nothing but it is the mass which is equal to the 1/12th of the carbon 12 isotope. It is the mass which is equal to the 1/12th of the carbon 12 isotope. So that's where we have the atomic mass unit. Fine? All of you have understood? This is what we have discussed, and please remember all of them. They are some of the important concepts. You should not forget. Fine? Any doubts in this? Okay, fine. Now, already we know what you mean by molecular mass or molecular weight. Now, we have another thing which is called as formula mass. We have another concept which is called as formula mass. Don't worry, there is no much difference between molecular mass and formula mass. Only thing here is where it is applicable, to which type of compound it is applicable, then only they are vary with each other. Okay? So molecular mass is a umbrella term or broad term. Formula mass is bit specific because it is majorly applicable for ionic compounds. It is majorly applicable for ionic compounds. So that's where we have the formula mass. Fine? So that is because if I take sodium chloride, okay, fine. If I take a sodium chloride, so where this sodium chloride will be, present as solid, a crystal, right? So when I will be adding this sodium chloride, if I take its structure, where it will be present as Na plus Cl minus, Na plus Cl minus, like that it will be present, right? In its crystal structure, it will be present as Na plus Cl minus. So that's why its crystal structure will be there. Now if that is the case, if this is where its crystal structure is there, now when I will add it to the water, it will get dissociated as, Na plus Cl minus. It will get dissociated as Na plus Cl minus. Okay, fine. So that's why we have the ionic compound, which will not be present as NaCl. It will not be present as NaCl. It will be dissociated. Okay. But when I am talking about glucose, covalent compound. Glucose is a covalent compound. Everything you are going to discuss in your chemical bonding class, and this one you are going to discuss in your second period, solid state. So that's where we have the glucose, which is a covalent compound, and NaCl, which is a ionic compound. So if I consider these two elements, both are of different types of compound. NaCl is ionic compound, it's a covalent compound. Now this glucose C6H12O6, it will not change. It will remain as C6H12O6 only. Okay? In its crystal structure also, or in its solution form also, it will remain as C6H12O6. So therefore, formula mass, it is applicable for ionic compound, where we are not going to consider this dissociation and all. Depending on their formula, we are going to have the calculation of the mass, same as that of the molecular mass calculation. All of you have understood? Fine. So therefore, based on the formula, we are going to calculate the formula mass. That's where it is called as formula mass. All of you have understood? The way we are calculating, once again, there will not be any change. It will be remaining same. Fine. So that's where we have sodium, which will be 23. Atomic mass of sodium will be 23. And chlorine, it will be 35.5. It will be 35.5. So therefore, formula mass of sodium chloride will be 58.5. Okay, 58.5. If you want to express it in atomic mass unit, then we can mention it as U or AMU or DA. Or if you are expressing in terms of molar mass, then it will become 58.5 grams. All of you have understood? So that's where we have the formula mass, which is applicable for the ionic compound. Otherwise, the way we are going to calculate, it will be same with respect to molecular mass or formula mass. There is no change. Any doubt? Any doubt up to here? Any doubt? If you don't have doubts, then we can move to the next part. Okay, so shall we move to the next one then? Next concept. Okay, fine. Now if you see the periodic table and all, if you see the periodic table, in our textbook also it will be there. If you see the periodic table and all, Then they will be giving, for example, if I take carbon, okay, so atomic mass of carbon, they will give it in fractions. There will be mentioning some fraction value will be there, 12.012, like that value will be there, right? 12.012, like that value will be there. Now if you observe it carefully, almost all the elements in the periodic table, most of them, they will be having atomic weight in the fractions. How it's possible? Whether we are going to have atom, if I consider this one as an atom, whether this atom will be present as a whole or a piece of this atom will have been removed. What is happening? How come it will be in fractions? Right? So that will be the question which will come to your mind. It will strike to your mind is, how come a molar mass of the element will be in the fractions? Right? Okay, fine. If one element 35.5, that is fine. For example, if I take Ravindra survey, it can be 64.5 or 65.1, that is fine. But here the reason for this decimal point is different. The reason for decimal points is different. The reason is different. That is because we are going to express molar mass or atomic mass of the element, especially in the periodic table. It has been mentioned with respect to average atomic mass. It will be expressed with respect to average atomic mass. So that's where we have the another concept, average atomic mass. 1 minute. So that's where we have the concept called as average atomic mass. Now when I am talking about average atomic mass, in the name itself it is there. We are considering something average. We are talking about average. So that's where average atomic mass. So what is that average? Now when I am talking about carbon, anyway, about the isotopes, we are going to discuss in next chapter, that is atomic structure. But briefly I will tell. When I am talking about carbon, we have carbon 12, carbon 13 and carbon 14. I am talking about atomic mass. We have three different types of carbon. So carbon 12, carbon 13 and carbon 14. So we have three types of isotopes of carbon. So why they are called as isotopes? Although all of them they are having the same atomic number, that is 6. That is 6. Whatever I have written here, it will be atomic number. Whatever I have written here, it will be mass number. Okay? So that's where we have the difference in that mass number. Okay, fine. In detail I will not go. If I take their occurrence, they will not be present separately. Please remember, if I go to the nature, if I take the carbon, in that carbon all these are mixed together. They are not present separately. But among them, abundant one will be this one, carbon 12. It is approximately 98.8 percentage. Approximate value. I am not talking about exact value. Approximately 98.8%. Next comes the carbon 13, which will be approximately 1.1 percentage. 1.1 percentage, percent occurrence. What do you mean by percentage? Anything which is related to 100. So that's where it is 98.8, abundant one. Then comes the 1.1%. And carbon 14, which is a radioactive form. Carbon 14, it will be having very less percent occurrence. So approximately 2 into 10 to the power of minus 14. Very less, almost negligible. right? So therefore, when I will take the carbon like this, say for example, if I am going to a stationery shop, okay, so where, for example, if I go to big bazaar, I want to take the rice. Now when I will hold the rice in my hand like this, when I will hold the rice in my hand like this, that whatever rice I am holding in my hand, it will be having mixture. Different grains will be together. Same way, when I will take the carbon from the nature, then naturally there will be presence of 12, 13, 14 together, right? So all of them will be present together. So now the problem here is, if I would have got pure carbon 12, I can take it as 12 gram. If I am going with atomic mass or molar mass, if I am going with atomic mass unit, then I can take it as 12 U or 12 delta. But that is not the scenario. There is an impurity of 13 and 14 also along with the carbon 12. So therefore, while calculating the average atomic mass, they will consider the percent occurrence. They will consider the percent occurrence of that particular isotope in the nature. Okay, observe it carefully. For carbon, I am going to show you. Fine. Say for example, for 100, how much it will be occurring? Approximately 98.8. So approximately 98.8. So in that case, how much will be there in 12 gram or 12 atomic mass unit? For 100, this is the amount of occurrence. How much will be there in 12? Right? So that is one thing. That is one thing. Plus, next another isotope. How much it is? 1.1. So for 100, it is 1.1. How much will be there in 30? How much will be there in 30? Right? So plus, for 100, it is negligible. 2 into 10 to the power of minus 14. How much will be there in 40? How much will be there in 40? So like that we can calculate. So naturally 98.8 divided by 100 means it will be 0.988. Fine. So 98.8 divided by 100 is nothing but 0.988 multiplied by 12 plus. What about here? 1.1 divided by 100 means 1.1 divided by 100 means, can any one of you? 1.1 divided by 100 means 1.1 divided by 100 means it will be 0.011 multiplied by 30 plus 2 into 10 to the power of minus 14. Oh, someone has written 100 and okay, fine. So it should be 0.011. 2 into 10 to the power of minus 40 divided by 100. It will become, if I take this 10 to the power of 2, this one as, for example, 2 to the 10 to the power of 14 divided by 100. I can also write it as 2 into 10 to the power of minus 14 divided by 10 to the power of 2. Fine. Now, yesterday we have shown, if I take this one upper, it will become right. So that is nothing but 2 into 10 to the power of minus 14 and minus 2. That means minus 60. It will become minus 60, right? So 2 into 10 to the power of minus 60 into 14. If I add it all these things together, it will become approximately 12.01. because I have skipped some of the digits here. It will become 12.012 approximate value. So that's how average atomic mass will be calculated. All of you have understood? So that's where average atomic mass will be calculated. Any doubts? Any doubts? All of you have understood? So while calculating the average atomic mass, what they will do? They will consider the percent occurrence. For example, if an element does not have any isotopes, then no need to worry. It can be directly given as atomic mass. But many of the elements they are having isotopes. So during that time we will go with the average atomic mass. And due to that reason, we are having in the periodic table most of the atomic mass which has been given in the decimals. Decimals in the sense 12 point something, like that the value has been given. Fine. So that's where we have the average atomic mass. Any doubts? So I think by this we'll go with the important one. We'll go with the very, very important one. I think I have not left anything. But any doubts? If you people have understood these things properly, then next concepts you will understand easily. Fine? Okay, fine. So next one is very, very important for your board exam. Very, very important. That is laws of chemical combination. Laws of chemical combination. Very, very important one with respect to your board exam. Okay? Fine. So we have different laws here. Among that, anyone they can ask. Many times they have asked. Okay? Among that, anyone they can ask. That's where we have the laws of chemical combination. In that, the first one is law of conservation of mass. Law of conservation of mass. Okay? So that's where we have the law of conservation of mass. So this was given by, this particular law was given by Anthony Lavoisier. Okay, it was given by Anthony Lavoisier. Anyway, who has given this law? They will not ask, but I am giving Anthony Lavoisier. So that's where we have the law of conservation of mass. Sir, for how many marks? Okay. If they are asking law and all, only law if they ask for 1 mark. Otherwise, if they are asking for 2 marks and all, then you have to give one example. Law of conservation of mass and all, it will be for 1 mark. Just you can define. Okay? So you should define what is that law talks about. Okay? So now, law of conservation of mass tells that, okay, fine. In the name itself it is there. Can any one of you tell me what can be the meaning? Conservation. We will tell now. It is the conservation forest. This is the forest which is conservative area where hunting or cutting the trees is not permissible. So conservation means protection or ಸಂರಕ್ಷಣೆ ರಕ್ಷಿಸುವುದು ಹೌದಲ್ವಾ. So here we are not protecting from anything. Here it tells that matters, what are matters? What are matters? Already we have discussed. Matters are anything which are having their own mass or dimension, right? So matters are neither created nor destroyed. Matters are neither created nor destroyed. That's where we have law of conservation of mass talks about. Okay? So matter can neither be created nor destroyed. Yes. So that's what it talks about. Law of conservation of mass. That is related to matters. Any doubts? So what I need to tell here is, if for example, I have sodium. Atomic mass of sodium will be 23. Now, I cannot create a sodium where a mass of sodium can be 13. I cannot create a sodium where mass of sodium can be 30. It's impossible. Right? So same way, when I am talking about sodium or any element, as I told, their mass will be constant. Their mass will be constant. It can be average atomic mass, but it will be a constant. All of you have understood? So that's what the first point or first law talks about. That is law of conservation of mass. Any doubt which tells that matters can neither be created or nor destroyed. That's what it tells. Any doubts in this? Any doubts? So second one is law of definite proportion. Law of definite proportion. Okay, which was put forwarded by Joseph Proust. It was put forwarded by Joseph Proust. So, if you remember the name, then only you write. Otherwise, don't write the wrong one. Don't write Joseph Priest. Okay, it is Joseph Proust. So, that's where we have the law of definite proportion. So, what do you mean by proportion? That means a ratio or pramana. So, right? So, that's where we have the law of definite proportion. Say, for example, I have the water molecule, a common molecule which we are going to discuss or which we are going to see in day-to-day life. Yes? So, that's where we have the water. What is the ratio of hydrogen and oxygen in water? That is 2:1. The proportion is 2:1. Hydrogen will be of 2 and oxygen will be of 1 because the formula is H2O. Right? Same way, if I take C6H12O6 glucose. Right? So where carbon will be of 6, it will be of 12, then oxygen will be of 6. Right? So that's where we have the proportion. 1:2:1. That will be the ratio. This will be the ratio, this will be the proportion. That's where it will be present. If I take hydrogen peroxide, it will be H2O2. What is that proportion? 1:1. Right? So that's where we have the 1:1. Yes, you are right. So that's where we have compound, where elements are combined in a definite proportion to form that particular compound. Right? If I take glucose, where 6 carbon, 12 hydrogen and 6 oxygen combine to form glucose molecule. If any one is getting changed, now that glucose will not be there. It will be a different molecule. Same logic. If I am talking about water, 2 hydrogen and 1 oxygen, they are combined together to form the water. If it will become 1:1, then the molecule will be different. It will become hydrogen peroxide. So that's what this particular law talks about. That's why it is called as law of definite proportion. That's why I told, if it is asked for 2 marks and all, then you should define the law, then you should give one example also. All of you have understood? So whether I will take glucose or water or peroxide in Mysore or in USA or anywhere on this earth, the proportion will remain same. Proportion among the element will remain same. Okay? So in that case, how we are going to define? Can anyone? In that case, how we are going to define? We can tell that a molecule or a compound, a molecule or a compound, compounds will be formed or will be having definite proportion of elements, definite proportion of elements, definite proportion of elements, right? So that's what we can tell. In a molecule or compound, it will be having definite proportion of elements, okay, by weight. Yes, we can include by weight, definite proportion of element by weight. So that's what I showed. See, for example, H2. So 2 grams of hydrogen, 16 grams of oxygen. It cannot be variable. So if I take H2O2, then it will be 2 grams of hydrogen, then 32 grams of oxygen. So that's where we have the definite proportion by weight. If that weight is getting changed, then the element molecule will be different. All of you have understood? That's why it is called as law of definite proportion, or we can also call this one as law of definite composition. Anything is fine. Definite composition. Law of definite proportion by weight, even that one you can tell, or law of definite composition by weight. That way also you can tell. One and all same. So that's where we have the another law. Any doubt? So it can be law of definite proportion or law of definite composition, or further we can tell that law of definite proportion by weight or law of definite composition by weight. Anything is fine, because here we are considering the composition with respect to the weight. Fine? Any doubts in this? Any doubt in this? Shall we move to the next one then? Any doubt in this? So next one is, okay, fine. Next one is law of multiple proportion. Law of multiple proportion. Law of multiple proportion, put forwarded by John Dalton. John Dalton. Okay, so that's where we have the law of multiple proportion. Now, if I take earlier example, that is water and hydrogen peroxide. Water and hydrogen peroxide. Whatever is that, this is water, and whatever I have written here, it is a hydrogen peroxide. Okay? So if I compare these two elements, what is that you can observe? What is that you can observe? What is that you can observe here? Water and hydrogen peroxide. Anyone? Or I will modify the question. It will be easy for you to answer. Which element is of different proportion here? Which element is with different proportion when you compare these two? Where they differs from each other? In which element they differs from each other? Hydrogen peroxide and water. Both are made up of hydrogen and oxygen. Very good, that is fine. But my question here is, in which element they differs? Yes, all of you are right. They differs with respect to oxygen. If you see the hydrogen, it is same. Amount is same. Hydrogen amount is same. Or I can tell weight is same. But oxygen is different. If I take with respect to the weight, here it is 16 gram or 16 atomic mass unit, it is up to you. Then here it will be 32 gram. Right? Since two oxygens are there. So now if I take the ratio, it will become 1:2. If I take the ratio, it will become 1:2. Right? 16:32 or 1:2. Same it is. Right? Or 1:2. So this is with respect to weight. This is the ratio among this element in a different molecular compound. So that's where we have the law of multiple proportion. That's what it talks about, law of multiple proportion. Now I can tell that when two elements combine to form more than one compound, mass of the element or weight of the element which combines with the fixed mass of another element will be in a whole number ratio. That's what it talks about. This particular law talks about when two elements are combined to form more than one element, that one compound. That means hydrogen and oxygen in case of the water and hydrogen peroxide. There are two elements, one is hydrogen and another one is oxygen. They are combined to form more than one compound, that is one is water, one is hydrogen peroxide. So that's what we have got the conclusion. Now it tells that mass of the element which combines with the fixed mass of another element. That means mass of the element, we are talking about oxygen in this example. We are talking about the oxygen. So the mass of the element, that is oxygen in this case, mass of the element which combines with the fixed mass of the another element, that is hydrogen in this case. Fixed mass of the another element, that is nothing but hydrogen in this example, will be in a whole number ratio. All of you have understood? So that's what law of multiple proportion talks about. That's why I told, whenever this one is asked for 2 marks and all, then you should go with example. Don't only write the law, you should not only defining the law, you should give the example. Fine? So that's where we have the law of multiple proportion, and this is one of the simple example. example. All of you have understood? Same way we have carbon monoxide and carbon dioxide. Both are different molecules or compounds, right? Now, carbon is constant, oxygen they vary from each other. Once again, it will be 1:2, whole number ratio. Carbon monoxide and carbon dioxide, right? So that's what this particular law talks about. Any doubts? Law of multiple proportion. Any doubt in this? So here, which element is in whole number ratio? That is oxygen. Here also that is oxygen. Which is that? Fixed element, fixed mass of the element. That is hydrogen here, that is carbon here. Fine? So that's where we have the example. Any example you can take, no problem. Fine? So any doubt with respect to law of definite proportion? All of you have understood? If you have any doubts, let me know. Okay, fine. So if all of you have understood, then we will move to the next one. So that is Gay-Lussac's law of gaseous volumes. So it is a person name. Don't go with gay, not that gay. It is a person name. Gay-Lussac's law of gaseous volumes. Once again, proportional. Gay-Lussac's law of gaseous volume. So that's what this law talks about. So that is nothing but proportion. There in earlier case it was with respect to weight. Here it is with respect to volume. Right? Since we are dealing with the gaseous molecules. Say for example, I have hydrogen gas which will combine with oxygen gas to form water, which can be in gaseous state at high temperature, right? So that's where hydrogen gas, in the bracket G stands for gas. Hydrogen gas, oxygen gas combined together to form the oxygen, right? Same way you can take anything. Hydrogen gas, chlorine gas combined together to form the HCl. Now, if you observe it carefully, if you want to balance the equation, please remember here it should be half to indicate that only one oxygen is involved. Or if you don't want, sir, half ella beda sir, we will go with whole number only. In that case, I can go with the 2 hydrogen which combines with 1 oxygen to form 2 water molecules. Same way here, hydrogen, chlorine combined together to form the 2HCl. All of you have understood? Fine. So if I go with the volume, if I consider this one as 100 ml, simply I am taking one volume. I am expressing volume in terms of liter. Okay. So I am taking it as 100 ml. Then how much it will be? Oxygen will be how much? Can any one of you tell me? Oxygen will be how much then? First, oxygen will be how much? Oxygen will be how much? Okay, Likita, very good. Oxygen will be 50 ml. Then water? Then water how much? Manjula. Okay, why 300? Okay, Shashank, fine. So how much will be water? It is for water if people have written, or 300 and 100, whether people have written for water or oxygen. Okay, so it should be, actually water should be 100, not 150. So many students, they will do that mistake. Don't add 100 ml plus 50 ml. No. There is no adding of these things. Just see the number. Here 2, I gave it as 100. Here 1, I mentioned it as 50 because half of this. Then once again 2 is there, it should become 100. Because during the chemical reaction, there is no gaining, there is no loss of any element. Right? So finally it should be constant. So therefore 150 combined to form the 100 ml of water. Same way here, how much it will be? If I take it as 50 ml, here if I take it as 50 ml, then that one will be HCl will be it will be 100, not 50. It will be 100 because here it is 2, here it is 1. Okay, so based on that we can tell. Fine. So what I mean to tell here is 50 ml of hydrogen, 50 ml of chlorine only will be involved. Or you can take 100 ml of hydrogen, 100 ml of chlorine, whatever it might be. So they will combine to form double the molecule of HCl. So 50-50 combined to form 100. 100 and 50 combined to form 100. Right? So that's where they are going to interact in a definite proportion by volume. They are interacting in a definite proportion by volume. All of you have understood? So that's what it's getting, its meaning is that. So if I see these examples, I can tell that two gaseous molecules, they are combined in a definite volume and they are going to form a compound. So right, so that definite proportion of volume, there it was definite proportion by mass. Here it is definite proportion by volume. Okay, so if I want to define when a gaseous molecules are combined to form a compound, will be to form a compound. Next, what we can tell will be in a definite or will be a whole number ratio by volume. Will be compound will be in a whole number ratio by volume. Whole number ratio by volume. But one condition should be there. One condition is applicable here. What is that condition? That condition is unless these gaseous molecules are at same temperature and pressure by volume, unless all the gaseous molecules, I can tell, all the gaseous molecules, unless all the gaseous molecules are at same temperature and pressure. We have to mention this one, temperature and pressure. We have to mention this one because if I change the temperature, then it's going to change. If I change the pressure, then naturally it's going to vary. For example, if I take earlier case, where hydrogen, oxygen, they are getting combined to form water, right? So now the volume ratio is 1:2. Sorry, 2:1. The ratio of the volume is 2:1 here. So it is 2:1 because 1 hydrogen, 0.5 is oxygen, 50%. Therefore, 2:1, the ratio of volume. It is a whole number ratio, that is 2:1. But if I am maintaining the hydrogen at one condition, that is different temperature and pressure, and oxygen at different temperature and pressure, then it can vary. It cannot be 2:1. There may be variation, right? So therefore, all the gaseous molecules should be at same temperature and pressure. So whatever hydrogen is having the environment, same environment even oxygen should have. Then only this whole number ratio will be maintained. Right? All of you have understood? So therefore, it can also be called as law of definite proportion. Law of definite proportion by volume. By volume. It can also be called as law of definite proportion by volume. All of you have understood? Gay-Lussac's law of gaseous volumes or law of definite proportions by volume. One and all same. So why they are telling this one? Because this one, if you take the example, hydrogen gas combining with the half of the oxygen gas with respect to volume, I am telling, to give rise to 1 molecule of water or 1 molecule of water gas, right? So therefore the ratio of gaseous combination is 2:1. Until unless hydrogen and oxygen, they are at the same condition, that is same temperature and pressure. All of you have understood? Any doubt? In case of the HCl preparation, it was 1:1. Hydrogen and chlorine gas, they are in 1:1 ratio with respect to that volume. All of you have understood? If I change the temperature and pressure, this is not applicable. So please remember, when you are defining this law, at the end you have to mention gaseous molecule should be at same temperature and pressure. That one sentence should be there, or that one word, same temperature and pressure, that one word should be there. Any doubts? Any doubts in today's topic? Anyway, I am going to stop here. But any doubt? Okay. So once again I will tell, check sheets, they are available in the college. You can get that one. Okay, that is one thing. Next one is whatever exercise will be there in your check sheet, exercise problems and all, it will be there. You should solve that one and you should submit that one to Rachita madam. Okay, so that will be like your homework. Fine. So in that case, if there is no doubt, I will stop here. Take care. Bye. Okay. And while coming tomorrow, just go through these laws and all. Practice them. Okay. So some is, are, if it is getting changed, no need to worry. But the whole meaning should not be changed. Okay. So when you are defining the law. Fine. Okay. Bye. Take care.